Hello everyone, welcome to the session. So now we have reached to the stage where I think it's a good time to discuss about the performance of the model. Until so far, we have already trained our model. We have seen the predictions of the model as well. And we have created a distribution plot for the same where, the residuals that we have find it out with respect to the difference between the actual value and the predicted value. We have seen that it's a normal kind of a distribution, but yes, on the left side, there is a kind of outliers which are very clearly visible, right? Now, let's try to see the performance of this model via the different metrics. So, if you are following from the very start of the session in this course, I have already talked about the two interesting metrics that we have in a regression algorithms, which is MSE and MA, mean squared error and mean absolute error. And I have already talked about what is the difference between these two. So obviously, I'll not go into the technical details for the same. I'll just try to show you how, in terms of implementation, we can directly fetch from sklearn this metrics, and we will try to see what numbers we will be able to get in this. Okay, so let's try to see from sklearn dot metrics. What we can do is we can simply import what we want to find out. Firstly, let's say I want to find out the mean squared error. So I can just fetch that mean squared error. Similarly, if I want to find out mean absolute error, I can directly fetch that as well, right? Let's say I want to calculate what is R square. So again, this R square, I already have conveyed in the previous video. So if there is someone who is not having the technical understanding of these keywords which I am mentioning here, please go and refer that videos which I already have discussed and then come to this implementation part, okay? Because I'll not discuss these things again and again in terms of technical part, okay? Now, what we're supposed to do is, let's say I want to print what is the mean squared error I am getting here. So what I will do, I'll say mean squared error, and obviously in order to calculate the mean squared error, we need the actual data and we need the predicted data. So you know that the actual values are available in the y-test, and the predicted values that we have stored is in the variable name, I think reg underscore pred, right? Regression predictions are there, that's why I have named it as reg underscore pred. Similarly, if you want, you can print what is the value of a mean absolute error, right? Similar to that, you can just write it down. What is y underscore test and what is reg underscore pred again. Similarly, let's say we want to print what is the R square score that we will be able to get. So you can print that as well. You can say print R2 square score, right? And here again, you can mention these two values, which is what is the y-test and what is the regression predictions that we will be able to get. Now, once you will run this particular code, there is some issue that we are getting here. Mean squared error. Is there any spelling wrong? Yes. Mean squared error. I think now it should be fine. Yeah. So here, if you will be able to observe, we are getting the mean squared error as 53%, mean absolute error as 52%, and the value of R square score is 59%, right? So what we want in our actual terms, obviously what we are looking for is a lower error value, whether it be a MSE or MA, right? MSE and MA both are indication of the error values, which should be very, very less. And we are looking for a higher range of values, maybe bigger than 0.7 or 0.8, approximately maximum it can be 1, right? Higher value of, you can say, R square score and adjusted R square score, right? Both we are looking for a bigger value. So obviously here, if you will be able to observe, the values are not that much closer to 1. The only reason is that in EDA part, there is a lot more stuff which we can do, which we can add on, as I already stated you while showing you the EDA part implementation, which I hope that you will do at your home. And maybe that can improvise these numbers, right? Similarly, if we will be able to see in the upcoming sessions how we will be able to remove the outliers, then again, that will help this performance metric to improve. So there is a lot more things to do. That's why this number is there. As of now, because it's the very first session, I don't want it to be implementation heavy. That's why I have taken it very smoothly, very easily. But in the upcoming sessions, you will see that at each and every time, we will keep on adding few more stuffs in EDA, so that you will be able to understand that how we will be able to get a better results, right? Better predictions that we will be able to form. Now, let's say you want to form the value of adjusted R square. So I hope you already aware about the formula of doing the calculation for adjusted R square, which is 1 minus what is the value of a R square score. So what you can do is, you can do one thing here. Maybe you can store this number inside this score value, right? And that score value, you can use it here. If we will be able to see now, x underscore test underscore norm. So please refer the formula of adjusted R square. So this is the formula to calculate the adjusted R square, which I already have referred again in my previous video. If there is anyone who is not aware about how we usually evaluate the adjusted R square, what is the difference between R square and adjusted R square, please refer the previous videos where I have conceptually illustrated all these things. It's just the implementation I am showing to you. So what is the issue here? Let me just check it out. What is this x test norm dot shape looks like to me? Let's see. So it is fine. It is 6192. I'm taking the number of predictors, which is, that's why I have taken the number as 1. Perfect. Minus 1, n minus k minus 1. So what mistake I am doing here is, if you will be able to observe, the score variable value, we are not inserting actually. So if we will print this score, we will not able to have anything here, right? That is the issue we are facing here. The mistake is I just copied it out, and that's the bad idea, to copy the things. That's why I usually prefer to write also. So here now I think score variable will have some value, and now it should, do the job properly. Now here, if you will be able to see, we will be able to get the value of a adjusted R square as well, which is almost approximately, if you will be able to observe, equivalent to the R square score which we are getting, right? So in this way, we will be able to get the numbers for MSE, MAE. If you want, you can also work upon calculating the RMSE. You, I hope, are already aware about the fact that the only difference between R square and MSE, RMSE and MSE is that we are doing a square root of that. So if you want, you can just print that RMSE value also. What you need to do is, the only thing that we're supposed to do on top of this is np dot square root, which we will take, and then I think the things will be fine. This will be able to give me the score for a root mean square as well, root mean squared error as well. So in this way, we will be able to evaluate all the performance metrics that we have in a regression part. Now the only thing which is pending here is that, okay, how we will be able to save the model. For that, we should understand there is something called as a pickle file. I'll talk about this in the upcoming session, that how we can save the file, and then in future, if let's say I want to open that file and want to gain the predictions with respect to that file without doing the training from scratch, how we can do so. See, in real-time scenarios, always remember that you will deal with a huge amount of data, and training requires a lot of resources, right? As of now, we are dealing with a very small amount of data, and that's why training happened very instantly in the recording itself. And intentionally, I can't pick up a huge data as well in the recording part, because it will take time, right? But in future, obviously, we will take a bit of huge data where I'll show you that, how you can use your runtime type from CPU to GPUs. And if you will take a Collab Pro, it will provide you higher configured GPUs as well. But as of now, what I'm trying to convey here is that if the file size is bigger, training takes a lot of resources. And what I want is, I don't want to use these resources again and again. Let's say in future, for more test data, I want to do the prediction. The bad idea is that you will start training again. Sometimes what happens is, if your data set is of image data, it can take 2 days, 3 days, 1 week, 2 weeks. So will you do the training again? No, not at all. So in practical real-time industry per se, we usually try to save that model in the form of a pickle file, and then we will use this pickle file in future in order to grab the results on the test data. So how we can do that? It's a very, very important step, which I will share in the upcoming video. So stay tuned. I hope that you will be able to get the understanding until so far, and you find these sessions very, very insightful. With this, bye bye everyone, and I'll see you all very soon in the upcoming videos.